Okay, so given zeros, or given the root. So if we said x equals a, if that is our 0 or our root, the factor for that is x minus a, right? We always do the opposite here. So if x equals 2 is a 0, then one of my factors would be x minus 2. If negative 1 is a 0, then a factor would be
X plus 1.
x plus 1. Okay, so that's step 1. Step 1 is to create the factored form where we write it as the factors. Now, if the directions say expanded form, or another thing they could say is standard form, let me write that out there too. Standard form, those are where we multiply everything back. Okay, so if I ask you for expanded or standard form of the polynomial, all you do is multiply this back. And so we do x times x squared. X times 1, 1x. Negative 2 times x, negative 2x. Negative 2 times 1, negative 2. Add like terms, and so the expanded form is this. X squared minus x minus 2. Factored form, expanded, or standard form, right here. Yay, that's it. Okay, except sometimes we have weird numbers. So, what happens if we have 3 zeros? Well, we had 2 zeros here, and what was our degree? 2. We have 3 zeros here, what will our degree be? 3. All right, so here we have 0. Now, the factor would be x minus 0. Is there any reason to write x minus 0? No. What do we write instead? Just x. So when we have 0, it's represented by the x. What would my next factor be?
X minus 0.
X minus negative 4, which becomes plus. And then, what's the last factor? X minus 3. So that is the factored form there. This is factored form. Now let's do expanded, and that's where we distribute or multiply back through on this factored form. Now, there's no real rules on multiplying. Multiplying is commutative, so the order doesn't matter. We could change up the order. I like to do my binomials together first, just my preference. Not the only way, not even the best way, just the way I like. So I will multiply the binomials first, and then I'll distribute the monomial. And so x times x is x squared. X times negative 3 is negative 3x. 4 times x is positive 4x. And 4 times negative 3 is negative 12. So this gives me x squared plus x minus 12. Now, to get to completely expanded form, I need to go ahead and distribute this x through. And we get everything a degree higher. So the squared becomes a cubed. The first power becomes a square. And the constant becomes 12x. Just distribute x. Okay, does that make sense?
Yeah.
All right. Now, this one is a fraction. When we write polynomial functions, when I have given you any problem that you've started with, have any of them had fractions in them? No. So what do we do with this fraction? Okay, what we do is this. We take this, x equals 2/3, and we kind of undo it. We want it to equal 0. So we would first undo the division. How do we undo division? Multiplication. So we get rid of that denominator by multiplying by 3. So now I have 3x equals 2, and I want it to equal 0, so I would subtract the 2. So the factored form for this one would be 3x minus 2. Now think about this in reverse. If I set this equal to 0 and solve, do you get 2/3? Yeah. So this is the beginning of factored form. All right, so you try the negative 1/4. See if you can come up with a factor that would give us a 0 of negative 1/4. Okay, did you get 4x plus 1? All right, now, some of you are really good at visualizing things in mathematics. And so I want to show you kind of the quick way, real quick. Whenever we have a linear factor like this, no matter what the numbers are, to solve it, we move the constant over. Maybe he's not behaving. There we go. And so we get ax equals negative b, and then we would divide. So every time we take a linear factor like this and we solve it to get a root, I need you to see that the denominator came from the coefficient. And the numerator came from doing the opposite of the constant. So if you can go backwards, you know that the numerator becomes the opposite of the constant, the opposite of the numerator becomes the constant, and the denominator becomes the coefficient. Do you see that? This became the coefficient, the opposite of this went here. This became the coefficient, the opposite of this went here. Do you see why? And then that's your shortcut. If that makes sense to you, you can do it that way. If it doesn't, do it this way every time. Just get it right. Whichever way is the easiest for you to understand. Okay, so we can finish up expanded form on this one by distributing. 3x times the 4x is 12x squared. 3x times the 1 is 3x. Negative 2 times the 4 is negative 8x. And negative 2 times 1 is negative 2. So my expanded form would be 12x squared minus 5x minus 2. All right, questions? Two more examples, then you are on your own. So we're going to do one with some imaginaries and one with some radicals. Now, in this example, I have given you 2 zeros. But there's more than 2. What's the one I didn't list? Negative I. Because if I is a root, then negative I must also be a root. Okay? So, don't let me trick you. If I only give you one, with the imaginaries, you know the conjugate must be there. So factored form would look like this. It would be x minus 2, x minus I, and x plus I. Okay, when we have roots or zeros that are opposites, once you write those as factors, you start here. Always start with your conjugates or your opposites. Okay? And the reason is, if you start here, it looks a lot nicer, a lot faster. So if we multiply these opposites here, every single time we do this, what happens to the outer plus the inner? Because they're opposites, they cancel. I'm getting positive ix and negative ix. They cancel. So all you have to do is the x times the x, which is x squared, and the negative I times the positive I, which is negative I squared. What is I squared?
1.
Negative 1. So this I squared is negative 1. What happens to minus the negative? Makes a plus. So this really becomes x squared plus 1. All right, so the completely expanded form would be my next step. And I'm going to force it to go in the right order. In expanded or in standard form, we always start with the highest exponent and we go down to the lowest. So we want that cube first. X times x is x cubed. Now I'm going to do the squared one. Negative 2 times x is negative 2x squared. Now I'm going to do the linear. x times 1 is positive x. Now I'm going to do my constant. Negative 2 times 1 is negative 2. If you didn't do it in the right order, you just have to rearrange it at the end. Not a big deal. Make sense? All right, last one. Okay. How about you just watch this one? This one's a little longer. I'll still post it to my notes online if you want it. All right, so same thing with the imaginaries. If positive root 5 is 1, then negative root 5 is 1. Oh, did I go too fast? Okay. If positive 2i is 1, then negative 2i is 1. Okay? So factored form is going to look like this. It's got 5 factors, doesn't it? X plus 1, x minus root 5, x plus root 5, x minus 2i, and x plus 2i. All right, so I'm starting with my opposites. I'm going to go with these two first. X times x, x squared. This is going to cancel with that. So the only other thing I have to do is negative 2i times positive 2i, and that is negative 4i squared. But what does that become? Plus 4. Negative 4i squared becomes a plus 4. I'm trying to switch colors. It didn't do it. There we go. All right, now let's go back and do these two. This times this is x squared. The outside and the inside are going to cancel. Now, a negative times a positive is a negative. What happens when I multiply a radical times itself? Square root of 5 times square root of 5. It is the square root of 25, which is just 5. Whenever you multiply a radical times itself, you end up with the square root of that squared. So it's whatever was under the radical. A radical times itself. So if I did square root of 2 times square root of 2, that is 2. Okay, so that one turned into that, and then this. And at this point, it's just preference. I choose to do these two because they look more alike. I could multiply those two together next. But I choose to do these two because they look more similar. So x times x is x to the x squared times x squared is x to the 4th. And then a positive 4 and a negative 5 is a negative x squared. And then negative 5 times 4 is negative 20. And now I have to distribute the x plus 1. And this gives me my answer. So I'm going to distribute the x in there. And I'm going to get an x to the 4th. And an x cubed. And I get x to the 5th. Excuse me. An x cubed and a 20x. And then I'll distribute the 1. So I get the same thing again. 1 doesn't change anything, so this stays the same, this stays the same, this stays the same. And then I just have to put it in the right order. So 5, 4, 3, 2, 1, constant. Okay, the back of yesterday's worksheet, you have 15 minutes left to get a good start on that. That is your homework.